Okay, so we're on page 30, and we need to talk about natural logarithms. This should really not take us very long. I don't think this is going to be anything too terrible. And then hopefully we'll get some time to start looking at some word problems with logs, but we'll save that for I promise they're not going to be bad.
Yep.
We'll deal with those when we get to those. Natural logarithms. I've mentioned these earlier in this unit, but we didn't actually do anything with them. A natural log is a log with what number for its base? E, which is not obvious at all, not like a natural number or anything like that. But natural logarithm, I want to get the definition down one more time. A natural logarithm is a logarithm with base E, with a base of 2.7, 1828, 1828, 459045, all that good stuff. 2.7, 1828, 1828, 459045.
Is that like a phone number? I don't remember any of what you just said.
Don't worry about that. It's a button on the calculator.
I know.
To evaluate natural logarithms. If we want to figure out the natural logarithm of 2, well, there's something really nice about common logarithms, log with base 10, and natural logarithms, log with base e. What's that nice thing that I'm talking about? You're thinking way too hard. You're thinking way too hard. It is not the same thing. What is really nice about both common logarithms and natural logarithms? And you have something on your desk that might... We're way over there. Alexa, what is so nice about those two types of logs? There is a button on your calculator for those things. We don't need any fancy change of base formula or anything like that. To figure out the natural log of 2, actually, since we're using this, I can just put my calculator under here. To find the natural log of 2, I think I just need the lights on.
I don't know how to use a calculator.
Natural log of 2, you're going to push the natural log button, the one that says ln.
But I got 7.
Hold on. Okay, just listen. I feel like we haven't really done anything and we're already making it way more complicated than it needs to be.
That's kind of what I do.
The natural log of 2, we're going to push the ln button, which should be on the same button as the e raised to the x button, because they're related, because the natural log is a log with a base of e. Natural log of 2, push enter. It should be, you can't see that, but it should be about 0.693. The natural log of 2 is about 0.693. If we wanted to check this and we did e raised to the 0.693, it should be pretty close to 2, because that's the whole point of natural logs. They answer the question, what's the power when our base is e?
I did e to 1.997.
No, we're not doing e to the 2. We want to find the natural log of 2. You are not going to use the e button, you are going to use the ln button.
Oh, I got 2.
You should not get 2, you should get 0.693.
No, e to 0.693.
Yes, should be about 2.
Yeah, that's good.
Find the natural log of 43. We're making this way harder than it needs to be. You are just pushing buttons on the calculator. That's really all we're doing. Natural log of 43.
3.7612001116.
Throughout everything we're about to do, I would like 3 decimal places. So let's go with 3.761. Alan.
So if the ln button is on the e to the power of x, is that way on the log button there's a 10 to the power of x?
Exactly, because those things are related. And we're actually going to see today when we're solving equations, we're going to have to go between, do we want a natural log, do we want an e raised to the? That's why they put them on the same button, because they're inverses of each other. Exactly. Let's look at some equations now. Letter A. I would like to solve the equation e raised to the x equals 20. Before we do this, I'd like to try another problem. You don't have to copy this down. I would like to look at the similar sort of problem, 2 raised to the x equals 20. How would you do 2 to the x equals 20? Base 2 of 20 equals x. And then you go to the calculator and solve, right? Hold on. Okay, back to the original problem I gave you. It's the same sort of problem. It's in exponential form. I'm going to write it in log form. Log base what? E. Okay, that sounds a little weird, but let's just go with it. Log base e of what? 20 equals x. Hold on. Do you see what I've done so far? Now, Log base e, there's a shortcut way to do that. Log base e means the same thing as what, Trevor? ln. Log base e means the natural log. So this means the same thing as the ln of 20 equals x. How would you figure that out? You just do ln 20 on the calculator. Because we can write it like that, we don't have to use the change of base formula because they're natural logs. You're going to go to the calculator and just type in ln of 20. 2.996. If I want an answer rounded to 3 decimal places, it is not 3. It is 2.996. If you wanted to check it and did e raised to the 2.996, it would be pretty close to 20. Letter B. If we write letter B in log form, what's the base of our log? Log base e of 7 equals 3x minus 1. But log base e means the same thing as what? ln, the natural log of 7. That means ln of 7 equals 3x minus 1. What I need you to do now is type in ln 7 on the calculator, get a decimal, and then go through the algebra to get the x by itself. No, okay. So in the work, if you don't show this line and go straight to the ln line, that's perfectly fine with me. But I do want to see a natural log in there. I do want to see ln. You can skip the step in the middle if you just realize log base e of 7 is natural log, so you don't have to show that. But I do need to see an ln. Get a decimal for natural log of 7, and then easy algebra to finish it off. You have an answer? Hold on. Remember, whenever we're working with these decimals, you're going to type it in the calculator, get a decimal, write 3 places, but actually use the much longer version that's still on the calculator to make sure we're accurate to the thousandth. Ellen, what do you have for a final answer?
0.982.
Good. 0.982. Do you see how this is working? These are just like our regular exponential equations, except the base of our log becomes e, which means it's a natural log. You're going to try c on your own. However, there's an issue we have to deal with first. What are you going to do? Divide by 8. So go do that. Divide letter c by 8, and then go deal with your logarithms. Let's see what we can do. I think it's a nice enough decimal, so you could use the decimal. Otherwise, we'd leave it as a fraction to make sure things are as exact as possible. What do we think? 0.458? Not terrible? Thank you, David. Next, we need to look at some equations that already start with natural logs in them. For example, letter A on the top of page 31, natural log of x equals 8. Well, a natural log is a log with what for its base? This original problem means the same thing as log base e of x equals 8. I haven't done any converting. I'm just saying natural log means log base e of something equals 8. Well, raise your hand if you think you have an idea how I might go about solving that. Jake.
Natural log of 8 equals x. Nah, I got it.
We'll go with Trevor this time. That's what we're going to do. We're in log form. I want to go into exponential form. So remember when we had like 2 to the third equals 8, the related form was log base 2 of 8 equals 3. If I want to convert this, there are no logs anymore. I get an exponential problem. Same deal here. Converting this is going to give me e raised to the 8th equals x. You are not on your calculator going to use ln for this problem. Instead, you're going to do e raised to the 8th. So on your calculator, you need to get to the e raised to the, on the graphing calculator, it's on the same button as the natural log key, because again, they're inverses. E raised to the, it automatically opens a power. On the graphing calculator, there is another place you can do this as well, but I think this is the easiest one. It should be pretty big. Give me 1 second. Yep. 3 places. 3 places. What is it? 3 places. 9, 5, 8. Ellen, what was your question?
Oh no, I was gonna ask if we still need a few decimal places.
Yeah, actually it does even say that right here in the directions. We're going to go to 3 decimal places over here. On your quiz, on your test, it will be very clear about how I want things rounded. Questions on A.
And you're not gonna take off points if you don't do this quickly?
I will not take off points if you don't. I will take off for bad rounding, but not if you don't show the squiggly equal sign. Do you think you could do B?
Yeah.
Try B. Do not go beyond B, but try letter B. And if you need help getting started, just calm down. Oh my goodness.
I feel sad.
The original problem means go quickly, please, John. The original problem means the same thing as what I just wrote, so go into exponential form and then just start dealing with some decimals and some easy algebra to solve that. And as usual, make sure you're showing all the algebra. I will be looking for every line of that on the quiz, like I always do with equations. That's nothing. If you can go straight from there to there, I'm okay with that as well. Shh. Over there on the side. Okay, leave her alone. Hush.
So I kind of went beyond B.
Didn't I say stop after B?
It's just
There's a reason.
big thing now.
There's a reason for things. Question, Ellen. Okay, what is it?
It's 48.804.
48.804. Is that okay? What's wrong with letter C that we can probably fairly easily deal with? 5. So what do you do first?
Divide by 5.
Okay, so watch. Let's kind of leave that as a fraction. Let's say natural log of x minus 1 equals 12 fifths.
I'm gonna go beyond it.
David.
It's so hard to like resist. It's like sorry, I need to stop. It's just
I can stop like giving the packets with all the problems in there if you're just going to keep going ahead.
It's fine. I won't tell you.
I think you can control yourself.
Yeah.
Okay, that means the same as forget it. Just go. Do letter C. Don't do D, but do letter C. And your power will be a fraction. I think that's fine. Leave it as a fraction. I mean, since it wasn't a bad decimal, the decimal would be okay. If it was a bad decimal, though, that you'd have to round, definitely leave it as a fraction. We'll see some of those in a little bit. Does 12.023 seem... Okay. Do you know what you did? That will make a difference. Questions so far? In letter D, we have 2 logs. Natural logs are like any other type of log. Those properties we know about regular logs. certainly still apply to natural logs. So D becomes the natural log of 5x equals 9. Finish it off. Finish letter D, and if you've already done it, just sit and wait, please. So log base E of 5x equals 9, e to the 9th? Yes, because they were getting added. If it was subtraction, you would have subtracted. But it was addition, so we add the stuff inside our logs. E to the 9th equals 5x. Problem, Martina? We're going to get this when we do e to the 9th. We'll divide by 5. We'll get 1,620.617. That is all I really want to do with natural logs. If there is an e in the problem, you need natural logs to solve it. If there were natural logs in the problem, what do you need to solve it? E raised to the whatever thing we're dealing with over there. There will be a few. So I mentioned before with that warm-up we did today, there are going to be 6 problems on your quiz. 4 were like the warm-up. The other 2 were something else. The other 2 were like these. One of the other ones on the quiz will have an e, and you have to do natural logs. The other will have a natural log, like what we just did, and you need to do e raised to the whatever. On the quiz on Tuesday. Okay. We have one last section we're going to look at. We need to look at why we actually care about logarithms. We need to look at some word problems. Now, the last time we did word problems, we looked at a bunch of formulas. Here, I'm going to give you all the formulas all at the same time. All the formulas we need are listed on this page. Do those look familiar at all? Yeah. Aha. Good news. We do not have to learn any new formulas. Somehow, we are still going to use the exact same formulas we had before. This would be good to listen to. For your quiz, remember that I told you if you did the quiz without formulas, you get extra credit. Otherwise, it's fine. What did I tell you, though, earlier about the test? For the test, you will need to have the formulas memorized. I can give you formulas on the test, but rather than extra credit if you don't need the formulas, I'll take off points if I do give you the formulas. Which would be better than not being able to do the problem at all, but we need to get these memorized. Absolutely. Once you get the test, you can write it on the top. And honestly, okay, the last formula, PERT, right? A equals P e to the RT. If you know the first one, you know the second one. Because they're the same thing, 1 plus 1 minus. I don't think doubling is that hard, and half-life is the same thing, just with a 1/2. I really feel like there's only one tricky one here. Yeah, the compounded interest one, where we'll stare at this for a little while, and we'll memorize things. Anyhow, what I would like you to do right now. Question? What I would like you to do. Percent increase, decrease. I would like you to read that example. I would like you to do letter A. Letter A is nothing new at all. There is nothing new about letter A. B will be different. If you don't remember how to do this, look back at 8.3. Hold on. I think the first thing we have to figure out is which of our 6 formulas are we using here? Which one are we using? Because I feel like you might have... Okay. Okay. Principal really just means dollar value, what you're starting with. A, we just kind of called A starting with. Yes, sorry. When you said the word principal, that kind of confused me a little bit. Yeah, I think you know all the numbers to plug in. You're not really going to use 4.5 though, right? Yeah, you got to make that into a decimal. Do that, please. Plug in. It's population, so I feel like there will be some rounding involved. Mike, work please. Hush and work. Yep, we need to make that into a decimal. So as a decimal, I'm going to move the decimal point 2 to the left. it's going to become 0.045. What was the time? How long was I waiting? 3. Would a decimal answer make sense in this problem? No, so when you get your decimal answer, you're just going to round to the nearest whole number. $15,559.8, so what should I say?
15,560.
Well, almost. What's the other thing we have to do with word problems? Janaea, put a unit. What are the units? Units or a label? What would we say here? People. Yes. Let me take a look at what you're doing.
What?
Not 13.635. That was the comma. Not the decimal point. Okay. And where did the pass go?
I put it back. That's what I was thinking too. No, I swear.
It probably fell. The girls' pass also
Oh
fell.
my gosh. Letter.
Walter had all of it.
Oh no, Walter has it.
Walter, 1 point, but there are 2 passes missing.
Yeah, Walter took it.
Okay, letter B. We want to figure out what the population, by what year will the population be double what it was in 2010? Watch very carefully. Do you know what the population will be when it is double what it was in 2010? What will it be?
Oh, I'm dumb.
27,000 what? Okay, so really, again, I really need you to focus here. We know what the ending population should be. It should be 27,270. Hold on 1 second. Let me fill that in. Do I know the starting population? That hasn't changed. Do I know my rate?
4.5% per year.
Sure. So what is that as a decimal?
1.045.
And-
Or 1 plus 1.
Yeah, 0.045. We'll add 1 to that and all that stuff. Do I know my power? We don't. Aha. We did this earlier in the unit, and we did a lot of guessing and checking. No longer. Okay, so hold on 1 second. Where did I get that from? Because we're asked when the population is double what it initially was. This is the initial population times 2. How do you deal with variables in a power? Oh. When there are variables in a power, we can find those. Excuse me. We can find those by using logarithms. This is an exponential equation. However, before I deal with that, I feel like I need to get this piece by itself. What do you do first? No. Divide by that 13,635. And it's actually a really nice number that I think should make a whole lot of sense. Why does that make a whole lot of sense? Because it was double. That's how we created the number in the first place. 2 equals 1.045 raised to the t. Actually, it may be easier if I just switch the sides. 1.045 to the t equals 2. What are you confused by?
Algebra.
What?
I don't know why it started off with whatever the equation was.
We're still using our same percent increase formula.
Yeah, but I don't. I just kind of cut through them because I don't understand.
Well, right,
why
but that's part of the problem. I need you to be doing all the steps, or no, it won't make any sense at all. We are starting with 13,635. If we're doubling, won't we end with 27,270? So we'll divide by that thing. We still have our 1 plus our rate, so 1.045. I'm dividing, that's all I've done so far. And I just rewrote the problem. Now, to figure out the power, when I don't know the power, I need to use logarithms. Watch. Log base what? It's weird. That's okay. Not base 2.
using the doubling time.
1.045. Of what? 2 equals t. Log base 1.045 of 2 equals t. How would you figure that out? What do you have to do?
Divide.
We have to divide, use the change of base formula, and remember it's always the log of the big thing inside divided by the log of the base. Go to your calculator, use your change of base formula.
I think I used the double.
Right, that wasn't the right formula. That was why I needed you to stay with us and not work ahead.
I just kind of wasn't there.
Can we get about 15.747 years? Any questions on what I've done so far? Well, so here's the thing. Now, if I was asking you how long it would take, decimals are perfectly fine with years. However, it was asking you in what year would this happen? In what year would that happen? 2025, probably like closer to the end of that year. But we're going to go with in 2025 because we were starting with 2010. I think on your test, I'm going to try to make sure I ask you, tell me the number of years rather than in a year. Or the question could be at the start of what year? At the start of 2015, at 2025, it wouldn't have been okay. 2026 would have been. How about I just ask you in how many years, and then we don't have to bother with.
So would the answer be 15 or 16?
No, in how many years? It's going to be 15.747 years. Decimals are perfectly fine. It would happen during the year 2025. Next example. Read the problem, please. Actually, what I want you to do is read the problem, figure out what formula you're going to use, fill in all the numbers, and then stop. Don't do any solving yet. Quickly, please. All of you. Should you be using percent increase?
No.
Percent decrease?
We have our end amount, right?
I think we have the ending amount. Do you know the time?
No.
No. Do not do any solving yet, please. Because there's a certain way I want to make sure we deal with this. I'm getting 500 equals 899 times 0.888 raised to the t. Will I need logarithms in this problem?
Yes.
Yes. When we get to the test, the problems where you just plug in and the problems you need logs for will be mixed together. If you know all the numbers on this side, you just plug in and you're good. If you don't know the power, we'll need logarithms. You can have questions like the last example with a part A where you just plugged in and a part B where you don't know the power and will need to use logs. So, can I use logs right away in this example or do I have to do something first? Divide. It is not going to divide nicely because I don't want to have to deal with like rounding, which might throw off my answer a little bit. How about I say when you divide, you just get the fraction 500 over 899. And I'm just going to switch the sides just because then that makes Mrs. Ebron's trick easier to use with the looping thing. It's a little tough to use when the exponential part's on the other side. We're going to go into log form. What is the base of our log? 0.888. Of what? Of that fraction. And you're just going to leave it as that fraction, 500 over 899, equals t. Go to the calculator, be careful with your parentheses, and let's see what we can do. Yes, we're using the change of base formula. 3 decimal places. We can have decimals when we're talking about measurements. And time is a measurement. That means 4 years and maybe like 11 months or so and a couple days and all that stuff. With money, 2 decimal places. With objects or people or something, no decimal places. Everything else, yeah, 3 decimals.
Yeah.
Question, David.
I got point.
Did you do log of the fraction?
Yeah.
Let me see how you type it.
I
Say that again.
I did 500 divided by 800.
And just wrote the decimal there. The problem is then you'd have to round that decimal, which means when we take the log of that and divide, it may did you get exactly 4.939?
I got 4.942.
Right, because you had to do some rounding there. To make it as exact as possible, don't. Leave it as a fraction.
would you just write 4.9? Oh, yeah, you did.
Are we done? Please read the problem on the top of the next page. Please read the problem on the top of the next page. Not on word problems. They're just going to be on the test. What formula? The doubling formula. That was the y equals a times 2 to the x formula. Do we know the a? 32. Do we know the x? What is x, by the way? What is x?
7.8.
Hold on. What do we call the x? Is x the time? Number of time periods. Do we know how many time periods we're waiting?
No.
We don't. We know how long a time period is, but not how many we're going to wait. I'm just going to say x. Which is good because do we know what we're ending with? 100.
So it says like how long it says to be the time.
Right. Are we ready for logarithms? Or do we need to do something first? Divide by 32. I don't really feel like simplifying that fraction. You don't have to. We can just leave it as 100 over 32 equals 2 raised to the x. Although I should probably write it the other way around. In log form, log with what base? Of that fraction equals x. Please type that in. But then actually we're going to need to be a little careful about something.
When do you use what's this formula called?
The doubling formula.
No, when you divide the log.
Change of base formula. Whenever we're trying to evaluate a logarithm with some base that's not 10. Can you get 1.644? Years? What does the power stand for in this problem?
Time period.
Not time, time periods. How long is a time period?
7.8 years here to divide it.
7. You do not.
Oh, cool.
Think. We have 1.644 time periods. How can I convert that to time?
That's what I'm saying, like, you see how many times it goes into 7.8.
We are not going to divide. That's what we did before when we had the time and wanted time periods. We need to multiply. We are waiting 1.644 time periods, and a time period is 7.8 years. We need to multiply here.
Wait, what would I have to say for us to divide? Like, what
To
would I-
divide, it would have to be a problem where you're given the time, and you want to find the number of time periods. We're waiting for 60 years. You would do 60 divided by 7.8, and you'd make that into your power. Hold on a moment. I need to pass out the cumulative reviews due next week because I won't see you tomorrow. Make sure number 20 comes in tomorrow. We will do more word problems on Monday, and we are truly finishing the unit Monday. We still have half-life ones and interest problems to do. Yes.
I have a random question.
Oh, wait, hold on. I need to give you the chapter reviews as well. So you're not like scrambling to do those on Monday. These are due on Wednesday. You really didn't want to get these on Monday. And
Well, you got the money?
uh-huh.
See, I don't.
Just come to my room.
Happy Fatties.
I probably could if I
No, we're gonna stop.